right. Well, I think we've got enough folks. We're going to go ahead and get started. I want to welcome you to our latest edition of Additive Essentials. Today, the topic is going to be nylon, and this is going to be all the different nylons. I'm not necessarily going to nitpick unless or differentiate much between the individual nylons unless somebody has a specific question regarding the nylon that you use or currently run. So this is going to be a little bit higher level, but all the stuff that we're going to cover applies to just running with nylon in general, because a lot of the settings are available for most of the nylons that FDM is available, or that is available on FDM. And some of it will depend on which machine you have. And so we're going to kind of talk about that as well, in case you didn't know that there was a nylon 6 material available, which is only available on the F900, which we have here. So if you have a need for nylon 6, we could potentially run that part for you here. All right, with that, I'm going to go ahead and share my screen, and we are going to jump in and start talking about nylon. So what I'm going to do just for this initial starting point is I'm going to select just nylon 12, and I'm just going to do the default of 10 thousandths, and I'm going to leave everything else alone for right now. The first thing that I want to point out, and in a previous session of Additive Essentials, we talked about the importance of using a sacrificial tower. I highly recommend this for all nylon. In fact, for nylon 12CF, you're going to see that it automatically defaults to turn on the sacrificial tower, and it won't let you turn it off. But even for nylon 12 standard, I would highly recommend using the full height capability of the sacrificial tower, because nylon material in general is a little bit sticky, and when it does its purge and it goes to wipe, sometimes that material doesn't quite wipe off, and it actually sticks to the head or sticks to part of the tip, and the sacrificial tower is going to help kind of capture and keep that from getting into your build. So if you guys know anything about nylon, it actually is a difficult material to extrude because it's pretty much either a solid or a liquid. And so Stratasys had to actually put modifiers into it to try to have it reach that in-between state. And that's what makes it a little bit extra sticky. And that's also why if you click into your support option, let me just load a file in here. Going to unsuppress this. If I look at that, the self-supporting angle for nylon is defaulted to 50. And part of that is because it sits in that intermediate state where it's semi-molten a little bit longer before it starts to solidify. And this is partly why we get excellent layer-to-layer adhesion with the nylon and the incredible strength with it. But the downside is it does require a little bit more support. So with that, I'm going to jump back into the settings that I want to talk about first. And that would be this system mode. Show of hands on your screen with the little raise your hand. If anybody, have you played around with adjusting the system mode? Normal, thin wall, and brick. Just give you a second to reply if you are aware of that. Anybody? No. Oh, one person. Excellent. All right. Well, then we have the right group on the call today. So in short, what system mode does is it actually changes the build envelope temperature. So as you can imagine, because we have this in-between state where it's a little bit softer for a longer period of time, if we have the envelope temperature at too hot of a temp for a really, say, thin wall feature, that's going to warp and distort. That's going to give you an undesirable part in the end. If we don't have it hot enough, what's going to happen is that larger area is going to attempt to cool too quickly, and then you're going to end up getting cupping or distortion where it wants to peel off the tray. So number one, I would highly recommend that you make a selection here based on your part geometry. Now, one thing to keep in mind, this is a per build setting because we're changing the entire envelope temp. And so if I have, say, a thin wall part and a really thick part, it might not be a very good idea to run those together because you're going to have one that's either going to curl or you're going to have one that's going to warp and distort. In that case, what we can do is we can use what we talked about in a previous Additive Essentials session, and that is use wall stabilizers or anchor pins to counteract that effect. So then you can actually build incompatible parts at the same time. But let's say we're just running one part. So what is it that we're looking for when we want to decide whether we are running normal, thin wall, or brick? So what it comes down to is the majority of the part wall thickness. So up to 200 thousandths, I'd recommend running in thin wall. Between 200 thousandths and a ½ inch, then I would recommend going with normal. And then anything a ½ inch thick or greater, you're going to want to run brick mode. Again, because we're actually changing the envelope temperature. Now, when in doubt, I would probably say stick with normal, which is obviously why it defaults to normal. So I'm going to go ahead and use my measure function, and I'm just going to measure this particular part. So you can see here that this base plate on this piece is 300 thousandths. So that means I would probably go to the normal range. But measuring a couple different areas, now I look at this area and I notice that, hey, that's a little bit less than 200 thousandths. And let's just see what this is up here. And this is also a little bit less. So what might happen if I go ahead and run this in the normal mode, because this area up here is a little bit thinner, I might get a little bit of distortion there. So you could potentially run this in thin wall mode. But then if I run this in thin wall mode, I'm worried about this 300 thousandths thick plate curling and lifting off the build tray. And that's where I'm going to go ahead and I can add in wall stabilizers to go around the outside of this to kind of help anchor that part down. So if you've designed the part and you know exactly what all the wall thicknesses are, you want to kind of look at the average. If it is a part that you did not design, then I would highly recommend use that measure function and measure in a couple different areas. Now, it also is going to matter depending on your build orientation. Anytime I have a large surface area, regardless of how thin it is, so let me hide this part. And I'm going to click on this part right here. Wrong part. Bear with me for just a second. Why are you not? Well, that's weird. Hold, please. Wow, that's really strange. I'm going to try to reload this file again here. Apparently, it's not letting me open it. AE² series, nylon. So much for trying to be prepared. All right, so I'm going to hide this one. Oh, wait a minute. There it is. Come down here, switch my units to inches because it's an STL. Now, this is a very thin part. Now, I get that it's not very big. It's not, doesn't have a lot of surface area. But let's say that it was much bigger. Let's go a lot bigger, something like this. And then we'll measure our wall thickness. We get to the right setting here. So that's saying that's about 0.2 inches. So in some cases, I've actually seen where the larger the footprint of a part, even though based on our number category, this would say to build it in normal, you could get away with running this in brick mode if you were concerned about it lifting. If you happen to run it in normal mode and then it does curl, then something to try would be to try bumping it up to that brick mode to heat up the build chamber, which will allow it to, the difference between the extrusion temp and the envelope temp is going to be a little bit closer together, which is going to prevent it from wanting to curl. All right. So I'm going to hide that one. Let me just go back to normal and see if that's the reason. That is the reason. So it goes by part. So because I had initially brought all these parts in at normal, that's why it wasn't allowing me to open it, because I had actually already switched it to thin wall. And so that's why it wouldn't let me open this thing. So I'm going to rotate this part. Now, for those of you that have been inside of our demo room, you might have seen this part. This one is, for the customer's sake, they actually built this in ASA. But let's say that I'm using a part for manufacturing assembly tool or a jig or a fixture, and I want that thing to be a little bit more durable, or I want it to hold up to maybe some chemicals, which is a big benefit of nylon 12 in general, is its chemical compatibility. But I don't need to build this thing completely solid. So let's say that I go ahead and I make this sparse. Now here's where it gets to be a little bit tricky, because even though my wall thickness, this part appears pretty bulky, as soon as I switch it to sparse, my wall thickness is only 60 thousandths. So I like to run sparse parts in the thin wall mode, because otherwise what I've actually seen is I've seen the side walls kind of sink in because they're only 60 thousandths. If you run it at normal, you could counteract that by adding a wall stabilizer, which is going to help kind of lock that in place and keep it from sinking or distorting. But that's where it gets to be a little bit of a mind confusion as far as the sparse versus, or your wall thickness, whether I'm talking about the full geometry or I'm talking about the changing it to sparse. All right, so that is one example. Let me go ahead and hide this one. Go back to normal. Show this part. Now, our owner of the company might recognize this part. So this is not a firearm or a gun. This actually goes on a fishing rod to give you a little bit extra grip as needed. So if I were to build this part, I would probably choose it in this orientation. As you can see, this area is very, very thick. But let's go ahead and just measure a couple of these other areas. So this is one of those cases where I have a thin wall that's attached to a very thick component. So now I have to decide, what mode do I try to run this thing in? Again, as I said, when in doubt, you could try normal, but then I run the risk of this part of it actually trying to curl or lift up. Otherwise, what I can do is I can switch this to brick, and then I can add wall stabilizers on the back side of this to make sure that this curve doesn't collapse or distort too severely. So ultimately, that's what I wanted to cover today was the different build modes. One other topic that I want to cover as far as nylon 12 CF. So if you run a lot of nylon 12 CF, you're going to notice that right here, it says use model material. So that means it's not building with support except where the support material touches your actual model. Everything else is going to be model. Sometimes that can lead to issues when you go to remove that support. It might be trapped, it might be locked around a geometry. One thing that we have found is that, well, one thing that I have found, my experience, is that anything 3 inches or less, then I actually will turn this use model material off, which means it'll all build support. And that way I can manually break away as much support as I can. And then the interface layers, I go ahead and I toss that into the tank. So that might be something to keep in mind that might help your support removal process. And then you don't have all those little chunks of model floating around your tank and potentially plugging up your the little impeller. If you are having challenges removing parts off of the build sheet, so this was something that we heard about with nylon 12 CF when it first came out. I do have a process, but it strictly uses Insight to modify the base layers to make it easier to remove. Some of our future sessions, we are going to talk specifically about Insight and why I might use it over GrabCAD Print. And one of those cases is where I want to modify the base layers to make it easier to remove the build sheet off, or to tear the build sheet off of the part without damaging my part or the build sheet. If I'm running Insight, when I first open up Modeler Setup, you're going to notice the system mode is right here. So we have normal, thin wall, and brick. And because I am processing just an individual part, when I go to save my files, I want to put somewhere in that file name a description saying that it's thin wall, because otherwise it will not let me pack that with other parts that have been built in, say, the normal mode. Because of the different shrink factors that occur on in the software when you're processing with thin wall, normal, and brick. Also, there is a different shrink factor if I'm building solid versus sparse double dense or hexagram. So that's also something to keep in mind. But we can deep dive in another session on how we can build parts in the wrong shrink factor or the wrong system mode, and then use wall stabilizers, anchor pins to go ahead and counteract the sinking or warping cases that might happen. Let's see, we kind of covered all that I was planning on for right now. It looks like I have a question here. Is there a way to turn off that default? Nolan, can you specify what you want to turn off by default?
Yeah,
Exactly?
sorry about that. Yeah, I was wondering if there's a way to make it so it defaults to not using model material for support.
Yes. I believe you can do that. And I'm trying to think. I believe that if you set up a manufacturing template, that's manufacturing notes, labels. I do believe that there is a way. I would have to reconfirm and I can get back to you on that.
Okay,
I
that'd be great.
know I know for sure there is a way within Insight to do that. And with Insight, if I come in here to modelers, I can save a custom build style. So anything that I change this to sparse. I'm going to change this to thin wall. And then my supports, I'm going to go here to setup. And I'm going to uncheck this, even though it's unchecked because I'm just on regular nylon. And then if I save that as a custom build style, anytime I load that build style in, it's going to automatically open up with all of those settings that I just changed with one button click instead of multiples.
Okay,
And I'm
we
pretty
use
sure
that.
there's a way to do that with GrabCAD Print, and that's by using a manufacturing template. But I have to refresh myself on where to do that. Fixture made, model operations, not there. Any other questions right now while I'm thinking in the back of my head on the manufacturing template aspect? Are there any special considerations to keep in mind printing with nylon, handling, storage, post-processing? All right, excellent question. One of the big obstacles is trying to prevent your part from warping or curling while it's building. But then we go to put it in the tank, and unfortunately, if we heat it up too much, it has the possibility to warp and distort in the tank. So anytime I'm running a nylon material through the tank, I select 50 degrees C, which is about 122 degrees Fahrenheit. So depending on what post-process support removal tank you have, you want to use the lower temperature. Now that does take longer, but this also does another key component to the nylon, and that is actually hydrate the nylon material, which gives it its durability and its flexibility. So if you are not tanking your nylon parts, I highly recommend to do that because that's where you really get your strength characteristics and your flexibility out of it. Because there is actually a mechanical bond between the support and the model layers. So the only way to remove it would be to mechanically sand it or grind it away, but then you're not rehydrating the part itself. You could just simply do that by just dunking it in some water after the fact. But otherwise, when it's out in the environment, it'll absorb moisture from the environment. Unless, of course, it's really dry, like we get here in the wintertime. As far as storage goes, nylon material is hygroscopic, meaning it wants to absorb moisture. So as much as that helps my finished part retain its flexibility and its capability, if I'm pulling out the material, I want to make sure I keep that dry. So on the Fortis stuff, that's fairly easy. We have a metal canister that has desiccant packs in it. Make sure that all the rubber seals are closed up and shut, the little door, and make sure that there's no filament extending out from the little snout or the cap. As far as running on the F series, the nylon CF10 and the Duran, Stratasys has foil bags. I've seen some customers use like a Rubbermaid container with desiccant packs in it to try to maintain the dryness. Anything you can do to help prevent that material from absorbing moisture before you run it in the machine is going to result in a much better, cleaner looking part. Any other questions? That covered storage, tank temperature, nylon 12 CF, 3 inches or less. One thing to go along with that, as far as the 3 inches or less, the reason that they build with model material is because of the different shrink rates between the model and the support material itself. And if you build, say, an 8-inch tower out of model and support, by the time you get to that 8 inches, the support's actually going to be a little bit low because it shrinks more than the carbon-filled material. Because of the carbon, it doesn't shrink as much. But if you break it up into 3-inch chunks, then you're going to be okay. So what you can do is you can actually use Insight, and you can go in and modify chunks of support material in approximately a 3-inch span. So that way you maintain your accuracy for your part, and you're not eliminating any potential build issues with your support being in incorrect height for the model. And that's one of those things that I plan to cover in a future session, is using custom groups within Insight to make some tweaks to the support structure. Any other questions? We've got just a couple minutes left here. We don't have any questions. I do know that our next Additive Essentials event is scheduled for February 17th, again at 10 a.m. And we are going to be covering PolyJet at that meeting. So those of you that are FDM folks, maybe it doesn't apply, but some of you have both FDM and PolyJet, or maybe you're just looking at PolyJet. And we're going to kind of cover some of the, I'll say, forgotten or missed settings or changes that you can make that can help lead to a better, more successful build. And that's going to also coincide with an open house that we have, where we have Colton from Stratasys coming to talk all things PolyJet. Well, it does not look like we have any questions, so I guess I will give you 2 minutes back from our scheduled meeting. And as a reminder, all of these are recorded, and they are on the AdvancedTek website. So if you did not catch the previous session talking about the wall stabilizers and sacrificial tower and anchor pins, I highly recommend checking them out. And I think that's it. Thank you all for joining, and we'll talk to you at the next session. Thanks.